Use a normal approximation to find the probability of the indicated number of voters. In this case, assume that 202 eligible voters aged 18 to 24 are randomly selected. Suppose a previous study showed that among eligible voters aged 18 to 24, 22% of them voted. So we want to find the probability that fewer than 51 voted. Now we want to first identify the values of n, p, and q. So in our problem, we can see that there's 202 eligible voters, so n is equal to 202. We know that the probability is 22%, so p is going to equal as a decimal 0.22. And the value of q is equal to 1 minus 0.22, which is equal to 0.78. And so now we're going to calculate the values of n and p and nq to check and see if they're greater than or equal to 5. So we know that n is 202 and we know that p is 0.22. We multiply those together. We want to make sure they're greater than or equal to 5. And then n times q is 202 times 0.78. We want to make sure that's greater than or equal to 5. So if we take 202 and multiply it by 0.22, we get 44.44, which is greater than 5. And then 202 times 0.78 is 157.56, and that's also greater than or equal to 5. Therefore, the normal distribution is suitable for approximating the probability. Okay, now we want to be able to find the mean and the standard deviation. Well, the mean is equal to n times p, which we already found in here, and 202 times 0.22 is equal to 44.44. Now the standard deviation is taking the square root of n times p times q, which gives the square root of 34.6632, which then gives us 5.887546. Now what we want to do is we want to be able to draw a normal distribution centered about the mean, which is equal to 44.4. Actually 44.44. So let me go ahead and put that in there. So it's 44.44. Okay, and then draw a vertical strip area centered over x equals 51. And since it is fewer than 51, it doesn't include 51, and we shade to the left of the continuity correction. So remember, since it says fewer than 51, we do not include the value. So we're going to go ahead and then draw our bell curve. So we know that our mean is 44.4, and we know that x, or the value of x, is equal to 51. Okay, so now what we want to do is find that continuity correction. Okay, now since we're not including 51, remember that the continuity correction represents the discrete whole number x by the interval of x minus 0.5 to x plus 0.5. Since we're not including 51, we're going to take 51 and subtract 0.5 to give us 50.5. So to the left of that is going to be 50.5. And then again, since it is fewer than 51, we're not including 51, we're going to shade to the left of 50.5. So let's go ahead and shade everything that's below that value, and that is the probability that we're looking for this particular value. Okay, so now what we want to do is we want to find the z-score that's associated with that. So remember that you want the z-scale. We know that this is 0. We want to find out what is the z-score that's associated with 50.5. And then rounding that to 2 decimal places. So recall that the mean is 44.44 and the standard deviation is 5.887546. So we're going to put in 50.5, which is the value of x, subtract the mean, which is 44.44, and divide it by the standard deviation, and we get 1.029291. Rounding it to 2 decimal places gives us 1.03. So therefore 50.5 is going to have a z-score of 1.03. And so we want to be able to find the area that's to the left of that. So let's go ahead and do that on StatCrunch. So we're going to go ahead and select refresh. Again, if you recall, in order to find that it's on StatCrunch, what we're going to do is go to Stat, go to calculators and go to normal. And so we want to make sure that our mean is 0 and our standard deviation is 1, and we're looking to the left of 1.03. And let's hit select compute, and then that's going to give us the area that we're looking for. So let's come back down here, and then the area rounded to 4 decimal places is 0.8485. So the area to the left of that is 0.8485 rounded to 4 decimal places, and therefore the shaded region in the graph above has an area of 0.8485. Hence, there is a 0.8485 probability that among the 202, fewer than 51 eligible voters will actually vote.